Okay, so to recap the properties that we just learned, if I have a product of power, or power of the same base being multiplied by another power, then I can add my exponents. For example, if I have x cubed times x squared, we know that if we were to expand this, that x cubed is 3 factors of x, and x squared is 2 factors of x, and that all together, that's 5 factors of x. Okay, so just a few examples here. One way this could look could be x squared times x to the 7th. So really kind of direct example of that. And if I have a power times a power, I can add my exponents, 2 plus 7. I can simplify this down to x to the 9th. And I could have more than one exponent there, or more than one variable there. So I could have x cubed y squared times x y to the 4th. So on this example, remember it has to be the same base. So I can combine this x with this x and say, well, I have 3 factors of x here. And if I have no exponent, that means I have a single factor of x here, which gives me 4 factors of x altogether. And then I have 2 factors of y and 4 factors of y, which gives me 6 factors of y altogether. Okay, so using more than one variable, we can do this. The last thing I want to talk about is when we have coefficients. So if I had negative 5x to the 7th times 2x to the 5th. Now this property only applies to exponents. So in terms of my exponent piece, I know I have 7 and I have 5, and altogether I have 12 factors of x. What students want to do is they want to apply this property again. But negative 5 and 2, these aren't exponents. These are just numbers like they've always have been. So negative 5 times 2 is still going to be negative 10. This is just regular multiplication of those coefficients. Okay, so it's important to keep separate the integer coefficients that are going to act the way they've always acted, and the powers that have these special properties, where if I multiply those powers, I'm actually adding up the exponents. Okay, so just something to be really mindful of. The next property that we did in our investigation said that if I had a power raised to a power, that I multiply my exponent. So for example, if I had x cubed squared, well, x cubed, meaning we have 3 factors of x, and if it's squared, then I have 2 of those, and altogether I have x to the 6, which is multiplying 3 and 2 together. So again, may give you kind of a straightforward example, but I'll give us one with 2 exponents. So if I have more than one exponent, really I'm breaking this down into 2 pieces here, where I have x to the 5th being squared and y squared being squared. Now I don't need to write that step. I just need to know that this will get multiplied and this will get multiplied, giving me x to the 10th, y to the 4th. Okay, that each of those powers I'm going to treat separately, but apply the same property overall. Last, let's talk about if we have a coefficient. So if I have 2x to the 7th squared, just like up above when we talked about this integer, this is still just 2. So thinking of order of operations here, right? 2 squared is still just going to be 4. And then when I do x to the 7th squared, that's when I'm using my property and saying, well, that would be x to the 14th, because I'm multiplying my exponents. The last thing we want to talk about, which really I already did here, is if you have more than one term. So as an example, x squared, y cubed squared, in terms of expanding this, x squared, y cubed would mean I have 2 factors of x and 3 factors of y. And if I have that squared, then I have 2 factors of x again and 3 factors of y again. And then all together, I have 4 factors of x and 6 factors of y. Okay, realistically, what we're doing here is we're just multiplying our exponents, but looking at what that looks like when we have more than one term inside of there. So let's give you a doozy of an example here. And this is why we don't always want to expand to figure out what the answer is. So here I have 4x to the 7th, y to the 10th, z to the 42nd squared. So reminder, this integer is going to act the way that integer is always acted. So 4 squared is still just 16. Then I need to make sure that x to the 7th gets squared, which multiplying gives me x to the 14th. That y to the 10th gets squared, multiplying exponents gives me y to the 20th. That z to the 42nd gets squared, multiplying exponents gives me z to the 84th. Okay, so there's my simplified expression, kind of almost like distributing that exponent through and making sure that each power gets multiplied and each integer gets treated the way we've always treated it. So I have kind of a way to remember and keep these properties separate, and that's P-man. So P-man stands for power, multiply, add, and nothing. And so what that means is that if I see a power to a power, you go to the next letter in P-man. If I see power to a power, I should multiply. If I see multiplication, then what I'm doing to my exponents is adding. And if I'm adding, I do nothing. So when I add, and so that makes sense in terms of going back into combining like terms, when we add 2 terms together that have exponents, we can just combine like terms. We can't add them together. We can't mush those exponents together, and we have an example of that down below. So when I look at my first example, and if I use P-man to help keep my properties straight, I look and I say, okay, well, multiplication is what's happening here. So that means I want to add my exponents, which would give me x to the 9th, y to the 6th. On the next example, I go, okay, P-man, I have a power here, which means I want to multiply my exponents. Gives me x to the 14th. When I get here, I go, okay, well, I'm adding, which means nothing's going to change, or all I'm going to do is combine like terms. So because these are both x squareds, we're just collecting like terms. We're saying we have 3x squareds and we have 2x squareds. So altogether, I have 5x squared. Okay, but notice that the exponent stays the same. It's still an x squared. We're just collecting and saying, well, I have 5x squareds altogether. It's the same idea as this. If I have 3x plus 2x plus 4 equals 10, and I say, oh, okay, so then I have 5x plus 4 equals 10, and then we could solve for there. We're just combining like terms. Okay, so addition, nothing changes with my exponent. I just combine the like terms. And then we're going to see our properties kind of all together. So here, first, I have, if I think of P-man, I go, okay, well, it's a power, so I should multiply, which makes this x to the 14th. And I still have that being multiplied by x cubed. And in my next step, I'm multiplying x to the 14th and x cubed, which means I should add those exponents together, giving me x to the 17th. Okay? So flip this page. Let's look at these again with some coefficients. So remember, we want to treat our coefficients like we always have. So when I multiply here, 7 times negative 2 is still going to be negative 14. Do not get those mixed up with properties of exponents. Then for my exponents, I go, okay, well, I'm multiplying. When I multiply, I add, and it gives me x to the 8th. Here I have a power, but this negative 4 is still just going to be, and I could write it separately. Right? If that's helpful, break it apart. Now negative 4 squared is actually going to be a negative times a negative and give me positive 16. And then for this, I think about my properties and go, well, powers, we multiply our exponents, gives me x to the 6. And here we have combination. So I can't multiply these together until I clear this parentheses here, which means first I'm going to square this 2x cubed. So squaring 2x cubed, so I still have this here. I'm not going to change it. 2 squared is still just 4. Remember, coefficients we treat as we always have. X cubed squared, that's a power, so I should multiply, gives me x to the 6. Now, so here we had a power, so we multiply. Now here we're multiplying across, which means for my exponents I should add, and I know I'll end with x to the 11th. My integers, it's still just 3 times 4. It's going to be 12, x to the 11th. Okay, same idea here. So in terms of this multiplication, it's still 12, but then for my exponents, I use my properties. So multiplying, I add x to the 8th. A power, 4 squared is still 16. X cubed squared is x to the 6. This is similar to up above. So first I need to clean up this parenthesis. So I still have 2x to the 5th. That will get multiplied by 3 squared, which is 9, and x cubed squared, which is x to the 6. Then when I multiply together, multiplying the integers gives me 18. Multiplying my powers, multiplication I should add, gives me x to the 11th. So now what I'd like for you to do is try the remaining problems. I'm going to do, let's do 11. I have like 3 minutes left of recording time. So let's do 11. And then I'll let you kind of try the rest on your own and I'll upload this key. So on 11, it's not any harder. There's just more terms here. So first I have to deal with this parenthesis, which means I'm going to square all of these terms. 3 squared is 9. And remember, when I have a power, I think about my properties, that means I'm multiplying. So 7, x to the 7th squared would be x to the 14th. Y to the 10th squared would be y to the 20th. Z to the 1st squared would be z squared. Well, I don't need parentheses there, but I'll put it there. Times, and I still have this first term. 4x to the 5th, y to the 6th, z to the 7th. Now, when I multiply these together, again, thinking about my exponent properties, when I deal with the exponents, I will add them, because multiplication, we add exponents. My integers, still just integers. So 4 times 9 is still 36. Then I have x to the 5th and x to the 14th, adding gives me x to the 19th, y to the 6th, y to the 20th, y to the 26th, z to the 7th, z to the 2nd, z to the 9th. Okay, so first I deal with any powers, then I multiply straight across, adding up exponents as I go.